In this video from ITFreeTraining, I will look at the new features in DNS for Windows Server 2012. There are only 2 new features, so let's have a look. The first feature is improved PowerShell support. With Windows Server 2012 in general, PowerShell support has increased across the board. In DNS, all user interface commands are now supported in PowerShell. Whatever you can achieve in the user interface, you can achieve in PowerShell. You can also add and remove the DNS role from PowerShell if you need to. The next feature is improved support for DNSSEC. DNSSEC essentially provides additional security for DNS, preventing DNS records and DNS transfers from being tampered with by an attacker. DNSSEC was available in Windows Server 2008, but it has been improved in Windows Server 2012. I will now have a closer look at the improvements for DNSSEC, but first a brief introduction to DNSSEC. DNSSEC stands for Domain Name System Security Extensions. It is essentially an extension of DNS that prevents data from being tampered with or faked. Traffic between DNS servers and the clients is not encrypted, so can be modified. For example, consider a primary DNS server and secondary server. As changes happen to the primary zone, these changes need to be sent to the secondary server. If you have additional security on your network, for example VPN or using IPSec to secure communications, this will not be too much of a concern. This is because even though the DNS traffic is not in itself encrypted, it is cased in encryption. If, however, this is not the case, a hacker can position themselves between the 2 DNS servers and change the updated information. For example, they could have the user directed to their fake website rather than the original website. The user would not even be aware that this is occurring. This is what hackers want to happen in order to get usernames and passwords or credit card details. The next point to consider is when a user performs a DNS query. This query is returned to the user, but the data is not encrypted. Once again, a hacker can send their own data back to the client. The hacker could change the data, they could send their own data, or they could send a message to the client saying the query could not be resolved and effectively cause a denial of service attack. So what does DNSSEC do in a nutshell? It provides a method to check that data has been changed. Once the client or a server receives DNS data, the data comes with a signature to allow the client to check that the data is authentic and has not been changed. This should give you a basic idea of what DNSSEC is. Now let's look at the new DNSSEC features in Windows Server 2012. The first new feature in Windows Server 2012 allows trust anchors to be seen in the DNS Manager that have been stored in Active Directory. Trust anchors are not a new feature, but previously you were not able to see a trust anchor in DNS Manager. So what is a trust anchor? Let's consider how DNS works. At the top of the hierarchy, you have the root hint server. This is where DNS servers start the resolving process. When DNS names are resolved, they are broken down starting from the right of the address and moving left. Each server in sequence knows the address of another DNS server that knows the next DNS server to pass the request onto until finally a DNS server is found that can answer the query. For this reason, it makes sense that the root hint server needs to be trusted. So the root hint server is what you would call a trust anchor. The root hint server contains a key that is used to create signatures for DNS data that is passed between servers or to the client. In the next step of the resolving process, in this example, is an AU DNS server is contacted. This DNS server supports DNSSEC, so it can use the signature of the root hint server. Basically what is happening is the root hint server is saying it trusts the AU server. The problem occurs when something like the following happens. The next server, a DNSCOM server, does not support DNSSEC. This becomes a problem because the last DNS server, the DNS server that knows how to resolve our DNS name, example.com.au, does support DNSSEC. The problem is that the chain of trust, as it is called, has been broken. There is no way that the DNS server can validate the data coming from the COM DNS server and confirm that it has not been tampered with. In the real world, there are a lot of DNS servers that do not support DNSSEC. As you can imagine, DNS servers are located all over the world, and it is up to the administrator in that country to configure the DNS server to support DNSSEC. Some countries may be quicker to adopt this technology, while others are more wary. When a client performs a DNS query, the client will want to confirm that data is accurate by checking the signature on the DNS data with root hint server. Since the chain of trust is broken, this is not possible. To get around this, a new trust anchor is created. If the client trusts the new trust anchor, DNSSEC can be used from that point onwards. On your network, you may use a domain name that cannot be registered, like a .local address. When this is the case, you will need to create a trust anchor for clients. The point to remember is, with Windows Server 2012, any trust anchor that you create, you will be able to view in DNS Manager. In Windows Server 2012, trust anchors are easier to use because of the last two features. In Windows Server 2012, the keys used in DNSSEC and their management have improved significantly. We already know that the keys can be stored in Active Directory. This allows them to be replicated with the other Active Directory data. With Windows Server 2012, there is support for automated key rollover. When a key is being used in DNSSEC, it will eventually need to be changed. Windows Server 2012 can now control this process, meaning the administrator does not need to worry about generating a new key before the old key expires. The last new feature in Windows Server 2012 is what is called the Key Master. What this essentially is a primary zone that can be configured to manage all the keys associated with that zone. This takes a lot of the work away from the administrator. The administrator needs to select a server that is holding a primary zone and configure it to be the keymaster. Only one keymaster can exist at once, but the administrator is free to move the keymaster to another server if they require. With the keymaster features, managing DNSSEC is a lot easier than ever before. Thanks for watching this video from ITFreeTraining. This is just one of the free videos from the DNS courses and the other courses available free of charge on YouTube or our webpage. Hope you found this video useful and hope to see you in the next one.